Einstein's Albert here, and the speed of light is a constant. Or is it? Well, actually it might not be, because the speed of light can change depending on reference frames, change depending on reference frames, including the time that it takes for that light particle to go across a distance. That is what we're going to be tackling today. Why it's like this. And what reference frame are we talking about? And also, what implications does this have to general relativity? Well, starting from the reference frame of a photon, or anything that is going at the speed of light, we can see that from its perspective, if it goes from like me, our home, the Earth, to a distant object that is billions of light years away, maybe even trillions, outside our observable universe, from its perspective, it would be instant, because as far as the light's concerned, doesn't exist. But we're getting ahead of ourselves. Why is this true? Well, from our perspective, we can see the light particle going at speed of light. From our reference frame, if it's going from one location to another location that's a light year away, it will take 1 year for that to do so. But general relativity says that in your reference frame, if you are moving, time goes slower. This is noticeable, of course, because we never move at nearly enough speed for this to be effective. But imagine a spaceship that's moving at the speed of light through space, and then suddenly it would not exist, at least from its reference frame. This is because at the speed of light, the time dilation rule that I mentioned earlier goes to an extreme. It just turns to zero. The time turns to zero, and time is non-existent. And if there's no time, there's no space. And without any space, there's no universe. And without the universe, the spaceship traveling at the speed of light doesn't exist. So, traveling at the speed of light itself would not work with our physical rules, because if we tried to do that, then we would get so many paradoxes that it would that the universe would break, and from your perspective, you wouldn't exist, even though you still have a perspective. You can't have. This is one of the reasons why massless particles, which travel at the speed of light, can't have reference frames. Since they are reference frameless, then they just cannot move from one place to another, and we cannot detect what it looks like from their frame, because they have no frame. They don't have a reference frame. They have no meaning, no time from their perspective, which doesn't exist. That's why they don't exist. They don't exist because they don't exist, as put shortly. Now, that might seem confusing. How would our spaceship traveling at the speed of light not exist from its reference point? We've all seen movies of spaceships going even faster than the speed of light, and time running normally. Yes, but we have a problem with that, because as it turns out, doing that is impossible. Going faster than the speed of light would require more than infinite energy, which makes no sense, and neither does infinite energy make sense. But the point is, if our spaceship is traveling faster than the speed of light, going suddenly from 0 to faster, then it would have to have literally negative mass. Literal negative mass, which wouldn't make sense. But also, even if we somehow manage to make negative mass using quantum mechanical observations that have been actually validated in very recently by scientists, then we could go faster than the speed of light. Except we couldn't, because of time dilation. Yes, time dilation comes back because as the faster you go, the slower time is for you. Eventually, if you're at the speed of light, time doesn't run at all. But if you're faster, time flips. Time and space flip. Time goes in the other direction. You'd be literally time traveling into the past. The only way to time travel into the future then is to not move, to be perfectly still. Time would run at its normal rate, and that spaceship would not exist because of general relativity. It wouldn't exist because it wouldn't exist, and it couldn't, and even if it did exist, couldn't have a reference frame because it would be traveling faster than the speed of light. It would have to have negative reference frames, which doesn't make any sense. It would have to have negative mass, which also doesn't make any sense. It just opens up a whole can of worms. It's impossible to make something that travels faster than the speed of light at all. But what if we tried? What if we really tried to go past the speed of light faster? What would we see from our perspective? Assuming that negative reference frames will exist, then you would see literally the universe. You would literally see the universe collapsing and then inverting, which makes no sense at all from our reference frame because we are bound by the universe's speed limit. Except it might not be that way because going at the speed of light might actually be possible. However, it would require such an exponential growth that even the most extreme of an extreme Lorentz transformation would not get you there. However, this doesn't mean that it's impossible. All you need is infinite energy. And infinite energy means no mass, because mass would slow you down. Mass is the actual reason why we can't go faster than the speed of light. It's not because it's a universal speed limit of sorts. No, it's because only massless particles can go at that speed, but not faster. Why? Because of negative mass. Once again, as I've said many times before, negative mass would be practically the only way to go faster than light speed. Because if your spaceship had negative mass, then it would literally warp space-time in such bad ways that you would literally get a warp drive. It's curving space-time in ways that would make space-time move, not you move, even though you're moving faster even though you are supposed to be moving, which makes no sense. Nothing can travel faster than the speed of light. And put even more simply, nothing can travel faster than the speed of light because of the grandfather's paradox. The grandfather's paradox is the real thing that's stopping time travel from the future or now into the past. The grandfather's paradox story goes like this. Imagine you have built a time machine and go into the past to kill your grandfather. However, then if your grandfather wasn't alive, then your grandmother would never have married. And even if you and your grandmother and grandfather were married even at the time that you went back in time to kill your grandfather, then he could not have transferred any sperm into a female reproductive cell, and so your mother would not have been made, which means that you would not have been made. It's impossible. And so that means that you would not have been made. But that means that your grandfather would have been made, which means that you would have been made. But that means that you would have killed your grandfather. And this is the real reason why time travel into the past is impossible. Without restrictions on human free will, which have no proof currently, it would be impossible to even attempt to go faster than light or to go back in time. Faster than light means backwards in time. And that is yet another reason why we cannot go faster than the speed of light. However, physicists using string theory have theorized hypothetical particles that could go literally faster than the speed of light. These are the tachyons. Apart from the fermions, the bosons, and the leptons, a tachyon would be a particle whose mass is an imaginary number, the square root of a negative number. This would, from somebody's perspective, from anybody else's perspective, from an outside observer's, that's what I mean. Then that tachyon would literally appear to split in two, and then one of them would be going at the speed of faster than the speed of light, and the other would disappear. Of course, nothing can disappear, not even elementary particles. However, there has never been a single hint of tachyons ever existing. If they did exist, even if they did exist, then that would completely violate the general theory of relativity, which, as I've mentioned before, bars anything from having negative mass, let alone anything from having the square root of a negative number as its mass. Nothing can have a mass of an imaginary number or a negative number. Everything must be positive. And that is yet another reason why we cannot travel faster than light. I could explain more reasons, but for now what I've said practically validates 100% that it's impossible to travel faster than light. As always, thanks for watching.